Hey guys, I'm going to teach you all about scatter plots and predictions. By the end of this lesson, you'll be able to model linear relationships on scatter plots with a line of best fit and use it to solve problems. So go ahead and get your binder, turn to the math section, let's go ahead and take some notes. When scatter plots demonstrate linear relationships and they form a straight line or get close to it, we can create a trend line, or what we often call the line of best fit, to represent and show the association between those two sets of data. A line of best fit, or a trend line, is literally when you see an association between data, like here I can see there's a positive association, and you draw a line through those scattered points, trying to touch as many as you possibly can. This is as close as you can get to the center of those points. That's why it's called the line of best fit. You're just trying to get the line that best fits your data. You can do the same thing with negative associations. Your goal is usually to try to get the same amount of points on one side of the line as the other side of the line. And this trend is trending down. It's a negative association. And again, it's not perfect. It doesn't match this data exactly because the data is all scattered around still. It's just the line that best fits your data. Now, you can't draw a line of best fit through a scatter plot that has no association. These points are scattered with no pattern, so there's not going to be a line of best fit you could draw that's going to really match this data. You can write the equation of your line of best fit just like a linear function. You're going to see that y equals mx plus b come back into play, where the b is where the y-axis intercepts the line. That's why that's called the y-intercept, and then m is going to be your slope. And we use that line of best fit and that linear equation to make predictions or estimate solutions for a given data set. All right, let's look at our first example with Farmer Joe here. He's a tomato farmer, and he's looking to see if there's a relationship between the number of bees that visit his garden in the spring and the number of tomatoes that he grows in the summer. Here's his data from the past 10 years. X will be the number of bees, Y will be the number of tomatoes. We're going to start by creating a scatter plot of the data given in the table. You do that just like you plot any other points. We're going to start on the x-axis looking for 45, and then we're going to go up to 68 and plot that as a point. And then I would check that off as you go. Next one, 38, 59. Again, go over to the 38 or about as close as you can to it, and then go up to the 50 and check it off. Now, in a linear equation, we'd just be able to connect those 2 points and graph our straight line. However, this is not a linear function. This is a scatter plot. So the points aren't going to necessarily follow a linear pattern. Look at the next point. And the next one. And although this doesn't form a perfect straight line, you should notice this is starting to form some sort of association already. Go ahead and finish plotting your points and tell me what kind of association do you see here. You should see that there actually is a pretty strong linear positive association between the number of bees in his garden and the number of tomatoes. We just created the scatter plot using the data in the given table. Now we need to use a straight edge and sketch a trend line. Remember, your line of best fit should have about the same amount of points above the line as below the line. It should try to cut through the middle of your data points. Go ahead and try that now and then press play when you're ready to check. Yours should be close to mine or look something like mine. But remember, it's just a line of best fit. So it doesn't have to be perfectly matching mine. But we can go ahead and start writing an equation that matches this line as best as we can. Starting with the y-intercept. Where does this line cross on the y-axis? I see that my line crosses at 10. And I'm going to count the slope on my trend line from point to point. And I'm going to use the points that are on my trend line. Not the points in the scatter plot, but the points that I just created. From my line, I count up 40 over 30. Where does that slope go in this equation? The slope goes in for m. And you'll notice I simplified 40 over 30 to 4 over 3. That's the same equivalent fraction. All right, now this is a question for you. How could this equation, this line of best fit, be used to make predictions about the farmer's garden for future years? What do you think? I think you can use that equation and plug in x or y values and find out how many bees or tomatoes he can expect. So if he gets a certain number of bees in the spring, he can expect a certain amount of tomatoes that could come out of it. It won't be exact, but it could be close to it. You can also create trend lines with your graphing calculator. You would input the data from the table into your graphing calculator, and your calculator should be able to find the equation of the trend line for you if you know how to do that. So that's what I did. I put in the values into the table, and then this right here is what gave me an estimation of the line of best fit. It told me that my M would be about 1.3 or 1.4, and my B is about 5.4, which is actually lower than what we saw on our sketched line of best fit. We had it crossing the y-axis at 10. This one's a little lower, but the computer or the scientific or graphing calculator is going to be a little more precise. But we don't actually need a graphing calculator for all these. We can do them using what we know about slope-intercept form and how to graph lines. So look at this next example. This graph shows a relationship between the number of curbside orders that a store receives compared to the number of customers that are actually shopping inside the store. What kind of association do you see in this graph? This graph shows a negative linear association. I would even guess there's a little bit of causation there too. But Stewart thinks that the equation that matches this relationship is going to be y equals 5x plus 200, where 200 is the y-intercept and 5 is the slope. We need to decide, is his equation reasonable for a line of best fit? Why or why not? The problem with Stewart's line is that it has a positive 5 as the slope. The slope should be negative to fit this situation. If it was positive, it would look something like this, when it should look something like this. We can use this line of best fit now to make a prediction. How many in-store customers would you predict if there were 18 curbside orders placed? Find that point on my graph and let's get to the nearest whole number. Looking at my line of best fit, I can see with 18 curbside orders, if I go up, it's close to 125 customers in the store. So 125 would be a pretty good, reasonable prediction. And we made that using our line of best fit on the scatter plot. All right, we're going to do 4 more check-in questions, then we're going to be done for the day. When I look at these 4 data sets, I have 4 different lines of best fit. Which trend line most closely matches the data in the scatter plot? You should have said C, because there's about the same amount of points on either side of this line. It goes through the middle of those points. How about this one? Which set of data has the best line of best fit? You should have said A. It's definitely not C and it's definitely not D. It doesn't cut through the data at all. The problem with B is that there's more points on this underside of the line than there are on top of it. This one cuts through right in the middle of those. There's about the same amount of points on either side of that trend line. Last 2 questions. In the form y equals mx plus b, what is the equation of the trend line that cuts through this scatter plot? Well, I can see that this y-intercept is 2, and then it counts up 6 over 7 from point to point. Last one, what's the equation of this trend line in slope-intercept form? So this one actually has the same rate of change as the last one. This one's just got a negative slope. It's decreasing. It's got a negative linear association. It also starts at 8 as the y-intercept. All right, guys, that's it. If you made it to the end of this video, I want to know, are you more organized or more scattered? Today we learned all about scatter plots and predictions, so now you should be able to model linear relationships on scatter plots with a line of best fit and use it to solve problems. So now you should go ahead and go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!